going to discuss this problem from Leetcode, problem number 207, course schedule. So in this question, there are a total of courses that you have to take labeled from 0 to num courses minus 1. Okay. Some courses may have prerequisites, which means that, for example, to take a course 0, you have to first take course 1, which is expressed as 0, comma 1. So it means to take course 0, you have to first take course 1. Okay. Given the total number of courses and the list of prerequisite pairs, is it possible for you to finish all the courses? Okay, so in this question, as you can see, this is a simple and standard question for topological sorting. So you have to do topological sorting, which helps us to find out what are the prerequisites are required to complete some other task. Okay, so we first discuss how topological sorting works, its example, and then I will tell you how the code works. This is also a very famous topic in interviews, and this question has also come in the latest Kickstart Google code round. So let's start. The question statement states that in this topological sort I have taken two examples. The first thing you have to remember that topological in sorting, to complete some other task, all the tasks before it should have to be completed. As you can see, if you want to build a cake, you have to first bring sugar, flour, etc. So you cannot do a further process before some prerequisites. Okay, so that's you can see here. To complete 3, you have to first do 1 and 2. It means that there is a arrow from 1 and 2 to 3. It means that first, if you want to complete 3, you have to complete these two tasks. So in the topological sorting, as you can see, for any task, the previous tasks are the one which have to be done before this task. So as you can see, I have written down here. So you can either done 2 or 1, it doesn't matter, but like I have written down here. So first I do 2, 1, then I do 2, and because these two are done, then I can do 3. Now, as you can see, to complete 4, you have to first do 5 and 3. Okay, so now as you can see, to complete, so thus we can do 5 easily. So now 1 2 3, then 5 is done. Now because 5 and 3 both are done, 4 will be done, and then after 4 is done, 6 can be done. Okay, so these are the topological sorting. There can be also multiple topological sorts, but this is one of the possible solution. Also, the second condition is there should not be any cycle present. That can be a case in which there is no topological sort present, because it means to complete 1 you have to do 2, but to complete 2 you have to do 3, and for 3 you have to first complete 1. So it completes the cycle, and thus you cannot do any of the tasks because they interdependent on each other. Okay, so that's what we do in the code itself. We will also find out whether there is a cycle in a directed graph. So it is actually called a directed acyclic graph. It is called DAG, in which there is no cycle, directed acyclic, because it has direction and it is acyclic graph. So if it is a directed acyclic graph, then true, we can form an answer. So for this we will maintain 3 like vectors to store the answer. Now what we will do is, there will be 3 states, 0 and 1, or like can be a -1, but we initialize everything with 0. So then what we can do is, we first store the total number of courses we have in a set. The set stores all the possible courses we are having. Okay, now we can start a topological sort at any of the nodes. Let's start with 1. Like you can start at 5 also, but we can start at 1. Like, okay, so now when we start at 1, what we will do is, we'll take this node and then we will process it. So what we will do is, we will mark it as visited. It means that we have visited it, so we mark the, for this we have visited it. Okay, and then also we will take this activated array vector, which will help us to know whether there is a directed cyclic graph or not. So I will tell you later in the example. So when we start at any node, we will mark it as 1. It means it is activated. Okay, now what we will do is, we will move to its children. Now we will move to this children, because it is not visited, we will make it visited and make it also activated equal to 1. It means this is also activated. Okay, now we will move to its children. We will, because this is not visited, we will move to its children, make it visited, make it activated. Now we will move to its children. So we can move to this node, this is visited, now we can also activate it. Now move, because this is also more children, move to this children, active, visited and activated. Now because this doesn't have any children, it means that this is the final one which is like undependent on any other node. This has to be the last one. Okay, so now the answer vector, or we can make actually a stack of it. We can make a stack of it, and then the stack last value will be this value. So we will push in the stack 6. Okay, because now stack 6 doesn't have any other children left, we will activation make it 0 again because it is now not activated, and we backtrack. Now does 4 has any more children? No, 4 doesn't have any more children. So now 4 must be completed after that. As you can see, it is making the value. And now also decrease it activation count. So why we are actually taking this activation count, let me take you this example first. So now what we can see, if I make this activated, we started this at topological sorting. We take our pointer to be here, make it activate and make it visited. Okay, now we move to its children, which is this. We make it activated and we said that we have visited it, so we marked it. Now we move to its children, because whenever we start visit an children, we will directly go to its children. We are actually doing a DFS. Okay, now we move to its children, we mark it and we make it activated. Now because again we move to its children, and because it is visited and it is marked as activated, it means there is a cycle, because we only remove our activation sign when we have visited all its children. It means that this direction set us back to one of the nodes which we have actually visited in this DFS, and we are going back to it. It means that we are going back to it, so it means there is a cycle. So we can make a variable which is named as bad, which can tell us that yeah, there is a cycle, and we make it 1. It means there is a cycle and we cannot form this topological sorting. I hope you understand why this activation is done. But now because we have visited all its children, we will make its activation equal to 0. Okay. Now we go back, visit all its children, make its activation equal to 0. Now we move to 5. Now because 5 has 2 children and we moved here, but when 5 next children will be visited, it is actually already visited through this path. So we need not to visit it again. And because now 5 all children are visited, we will push it in the stack. Okay, now we move to 3. Now 3, as you can see, 3 has 1 children visited, and now we have to visit next children, but because it is already visited, we will move to 3, and because all the children of 3 are visited, we will push it in the stack. Now we move back. Now we can, because we have started from 1, we will push 1, because all children are visited. Now because all children are visited, our set will contain every possible course, because we will iterate over our set, and because now we will choose some other random node which is not visited. Now this is not visited, so because all of these children are visited, we will again push it. So why we done it? Because we don't want any of the course to be left. Okay, this is also possible. We can first do 2 and then do 1. I hope you understand the logic. So now move to the code. It is also the same. I have made an adjacency list for the graph, which will direct us which direction every edge is. There is a set to store all the possible courses. There is an activation vector and there is a visited vector. Okay, and there is a stack to store the final answer, and there is a bool variable to store whether anything is bad or not. Then what we'll do is we will first iterate over our priority these vector which consist of all the prerequisites, and for every prerequisite what we can do it, because both of them are any of one of the courses, so we have to insert both of them in the set, so that the set consists of all the possible courses. After inserting them, we will make our what we can do, we will make our edge from this to this, because this must be completed first, then this. So it means this has an edge to this. So it means this is the first value, this is the 0th value. So there is an edge from this to this. Okay. Then we initialize a bad to 0, which means we first consider that it is a DAG. It doesn't have any of the directed cyclic graphs. And then we iterate over our set one by one, and we will only iterate if it is not visited. Because as you can see, if we start from 1 and we have visited all, now we visited 2, and because 2 is not visited, we will do again our DFS, but then we come to 3, because 3 is visited, we will not do this whole again, because we have done this earlier. Okay, then thus we will visit only DFS initialize only when it is not visited. Okay. Okay. Now we will come to DFS function, in which what we will do is first mark everything visited which I have done. For whenever first mark because it is visited, mark it visited and make it activate. Then what we do, we make it activate. Then we'll move all through its children and we will check if this children is also activated. It means that because this children is also activated means because actually you can see uh, when we come from 1 to 2, the children for 2 is 3 and the children for 3 is 1. So this is actually a children. Okay, so what we can do is, because this is actually a parent first and then it become a children. So for every parent we first initialize it at 1, but if any of the children again is activated, which means we have completed a cycle, and thus we initialize a bad equal to 1, it means we have find a cycle. Else if there is a no, we have not encountered this condition, we will only do a DFS on those children only which is not visited. Okay, if it's not visited, we will do a DFS on again for those children. And when we come out of this loop, we have to make our activation of that parent equal to 0. It means that we have traversed all the thing. And then because this is the one which is after visiting, which is the one which is the end. So because it must be pushed in the stack to find out the prerequisite answer. Okay, so if this vector is for this stack is formed without this bad variable is touched, then the answer is like, if this bad become 1, then the answer is false. It means it has become 1, so we have find a cycle. Else it is true, it means that we don't have find a cycle. So that's the code. I hope you understand the logic and the code. I have made it as simple as possible. Thank you for watching this video. If you like this explanation, please hit the like button and subscribe to my channel. I'll see you in the next one. Bye.